Hello, I'd like to welcome you to today's webinar on nitrogen management in organic strawberries, challenges and approaches. This is your host, Alice Formiga from the eOrganic Community of Practice at eExtension. You can find all eOrganic articles, videos, and our many upcoming and recorded webinars on organic farming and research topics on our website at the link on your screen. Before we begin, I'd like to give you a very quick overview of today's program. The presentation will last about 45 minutes, and after that, we'll have 30 minutes for your questions. We'll be reading the questions out loud after the presentation is over, and we will answer as many as we can in the time we have. So today, I'm very glad to be welcoming Joji Muramoto and Mark Gaskell. Carol Shannon, who is the lead of the NIFA OREI project on organic strawberry production in coastal California, also contributed to this presentation, but she couldn't be here right now. So Dr. Joji Muramoto is an associate researcher of the Department of Environmental Studies at the University of California, Santa Cruz. He's been working on fertility and soil-borne disease management in organic strawberries and vegetables in the central coast of California since 1996. Mark Gaskell is a farm advisor with the University of California Cooperative Extension. Mark joined UC in 1995, and since that time he's been responsible for research and educational outreach programs for small farms and specialty crops in San Luis Obispo and Santa Barbara counties. Now I'm going to hand things over to our first speaker, who is Mark.
Okay, good morning everyone. I'm pleased to have the opportunity to share with you experiences from field trials that we've been involved in principal strawberry growing districts of California over the past several years, that have really allowed us to evaluate and develop the key elements of nutrient management programs for organic strawberry production, and especially some of the challenges related to nutrient management. So this morning, to give you a brief overview of our presentation this morning, we'll review organic strawberry production in California, the general production system. We'll describe for you the specifics of nitrogen management, especially focusing on nitrogen nutrient management in organic strawberry production, and some of the challenges of synchronizing end supply with plant N uptake, some of the challenges for end management generally with organic strawberries, uptake patterns for nitrogen with organic strawberries, and then end supply patterns for organic strawberry production. I'll describe for you results from a recent fertigation efficiency trial, and then Joji will explain some additional trials, field trials with pre-plant and in-season nitrogen management for organic strawberry production in the Northern District, and give you an overall summary and give you some a review of some future needed work. So quickly to review for you strawberry production in California, it really represents about 85% of U.S. production, currently 38,000 acres, a little over 38,000 acres in 2015, and about 25% really of world strawberry production. So strawberry production is based in California principally along the coast of California, the three coastal areas from the northern area in Watsonville, Salinas area, central where I'm located in Santa Maria, and then the southern region in Oxnard. And the reason that strawberry production is so important and traditionally has been so important in California is that this coastal part of California is a Mediterranean climate, and even beyond that has very cool, dry summers and relatively mild temperature winters, rainier winter period. But this allows for a long, extended harvest season. In many cases, plants are growing year-round, and harvesting can be year-round. But to give you a little overview of what our annual strawberry cropping is in California, the traditional system is based on preparing beds late August, early September, preparing fields and putting up beds for transplanting, often goes into October. Transplanting process is typically October and November, and then in-season maintenance can last traditionally until the following midsummer when the fields are turned over and replanted. Harvest typically starts in the central district in February, and that varies a little bit. Southern regions earlier and the northern regions later. And then, of course, there's been many innovations of this overall system in the past few years, based on especially the manipulation of day-neutral varieties, have enabled plant transplanting in a much longer extended period. It has enabled cutback of plants so that we see, in many cases, production extending for a year or in some cases multiple years. So there are increasing modifications of that, all of which contribute to strawberry plants being out in the field over most of the year. So if we quickly go through our production cycle, we would be preparing beds typically in August or early September, and this would be, of course, the time when you might have the opportunity to incorporate prior plant residues, pre-plant compost, or green manure application, or organic fertilizer application. So this is the time when you would be incorporating your pre-plant materials that might provide early N nutrition to the plant. And then going from that, of course, there can be a huge difference if you have working with higher organic matter soils. The soils in the central region can be 1% or less organic matter, and varying in some areas up to 3, 4, 5% organic matter. So the ability to manipulate organic matter, which has traditionally been the basis for efficient organic production, can be somewhat limited in those areas where overall organic matter is relatively low. You, of course, have the opportunity to turn in residues and turn in green manure crops and add compost and so forth with this pre-plant operation. But then following this pre-plant soil preparation, additional preparation revolves around putting up plastic mulched beds and laying drip tubing underneath the drip tape, underneath the plastic mulch, and then a transplant process based on bringing transplants from the cooler northern region, and in some cases they're stored in refrigeration and so forth, so coordinating the cycle whereby transplants are used in the field. And then finally, establishment and early growth of the plant taking place at the end of the year and in January and early February. So my point by all of this is that a considerably extended process takes place in preparing the fields and beds and adding drip tape to the beds with our current strawberry production system as practiced in California before the plants get growing much on the beds. So you can see where in many cases we're now 4 months perhaps into the cycle before the plants are really growing appreciably, and then those plants may be out on the bed for a very long period of time, certainly 6 months, and oftentimes to a year or a second year in some cases. Now, if I just to give you a brief summary of organic strawberry production in California, it's currently at around 3,400 acres, a little over 3,400 acres, about 9% of total strawberry acreage. And you can see that it has continued to increase from 2000, and really organic strawberry production has been commercial organic strawberry production has continued to increase over the past 25 years, each year for the past 25 years. In California, and there are growers and farming operations that have been growing organic strawberries for 25 years or more. So there are growers and farming operations with considerable experience in growing organic strawberries, but even so, the yields remain 40 to 60% of conventional strawberry production. We're going to focus on nitrogen because as the key nutrient in managing nutrients for organic strawberry production, because nitrogen, of course, is often the primary nutrient limiting plant growth. There are inorganic forms of nitrogen in the soil, principally nitrate and ammonium, and there are, of course, organic material, different forms of organic nitrogen based on the turnover of organic matter in the soil. So organic nitrogen sources and any type of organic amendment has to be mineralized to an inorganic form to be absorbed by most crops. There is, however, rapid turnover of nitrogen in the soil. There's microbial activity is a basis for turnover and breakdown of soil organic matter. Nitrate itself, the inorganic form, is soluble in water, and so it's a fairly dynamic situation with the continuing microbial activity turning over nitrogen in different forms, and then adding to that the potential for soluble nitrate to be leached, and coinciding with our winter rainy period. We typically have rains between October and March or April in a typical year. So one of our primary issues that we've found over the past several years with our field studies is that synchronizing nitrogen supply with nitrogen demand can be an important limitation and a critical challenge for us, because matching nitrogen supply in terms of amount and timing with the need of strawberry plants and the growing conditions can be an important aspect of efficient management of nitrogen and organic strawberry production. So that's, of course, this efficiency is important for the overall efficient use of nitrogen as a resource. It's important in protecting ground and surface waters from excess nitrate. If you're applying huge amounts of nitrogen at one time during the season, and then that period is followed by high winter rainfall, that can be a serious problem with regard to nitrate loss and eventually contamination of surface and groundwater. Of course, and fertilizer cost and nitrogen fertilizer expenses can be problematic, or can be increased beyond the otherwise critical need if we aren't careful in the way we use it. And then, of course, the availability and the timing of and availability for the plant is very critical for strawberry yield. So our challenges then is that we have this extended harvest season, in a typical year, December to June in the Southern District, or February to August in the Central District, or March to November. And now with day-neutral varieties that may be cut back in late summer and kept around for harvesting into the fall and early winter, you can see where plants are out there year-round and are dependent on nitrogen availability and nitrogen supply during that entire period. Now, soil organic matter can be quite variable. I mentioned to you previously that in some of our growing areas in the central region, we can have 1% or less of soil organic matter. These are sandy loam soils. And in all areas, we have an unpredictable rate of soil organic matter mineralization. So it's a more difficult challenge to control nitrogen supply over an extended season such as this. The release from pre-plant incorporated organic matter does not necessarily coincide with plant end demand in the majority of cases, and then added on, we have the additional problem of the potential for leaching of nitrate forms or soluble forms with winter rainfall. This is some data generated in the Northern District from some studies a few years back that Joji was involved in which you can clearly show on the left the availability of nitrogen in the soil as you from pre-plant incorporated broccoli residue and the pre-plant incorporation of nitrogen fertilizer or compost, and you get a burst of early nitrogen that lasts typically for 6, 8, 10 weeks, but then that is also taking place at a time of the year when rainfall is just starting, and you can see from the bottom blue bars that rainfall during that period of time then exacerbates nitrate availability in the soil and can actually lead to increased amounts of nitrogen leaching, and so that overall soil nitrogen falls during that entire period of time, and plant uptake, illustrated by the red line, really hasn't even begun yet, because the plants were just transplanted in November and late October, and so they're just getting started, just getting established in the bed, and you don't see appreciable uptake until the point at which nitrogen from pre-plant sources has already fallen considerably and is really down below 50 pounds of nitrogen in the top foot of soil. So you can see where our challenge is even more seriously exacerbated on low soil organic matter soils, because we have such limited options for the manipulation of soil organic matter because of this asynchrony, which is a way to describe it, between pre-plant incorporated organic matter that's traditionally used in many organic production systems from either green manure crops or residues from a high, in this case, broccoli residue, or compost application, organic fertilizer application. All of those materials are basically have released their nitrogen with the initial mineralization from microbial activity in the soil prior to the time that the plant needs it. And so there were really limitations in these types of alternatives. And then I'll illustrate for you that there are additional problems when we get to in-season fertigation, injection of organic fertilizers through the irrigation system. So this is some additional data that basically shows you along the bottom graph the uptake of nitrogen by strawberries over the course of the season, and really the very little uptake, 20 pounds of nitrogen per acre, is all that we can expect for the first 4 to 5 months. And you can see that the plant eventually starts taking up nitrogen at a fairly high rate, but you have basically expended any type of pre-plant nitrogen availability, and if you do not have a soil organic matter reservoir to fall back on, you can see where the plant could encounter a shortage of nitrogen adequate for plant uptake. And that data was then confirmed largely by additional study that we did with on 25 farms over 2 years in both the Santa Maria area in the Central District and in the Watsonville area of the Northern District, showing very similar results with a large number of commercial farms, essentially showing from plants that were transplanted in October and possibly into early November, there's not appreciable uptake, really looking at something like, even by April 1st, less than 50 pounds per acre of nitrogen has been taken up by the plant. But you can see where it eventually reaches a point in here by mid-April or early May where plants can be taking up nitrogen very rapidly, and in some cases reaching a pound of nitrogen per acre per day of nitrogen need. So you can see where we have some serious problems with nitrogen supply, and organic growers and other types of vegetable and fruit production systems concentrate on manipulating soil organic matter as the basis for organic production. The mineralization of residue, cover crop, or compost basically lasts for most of our studies have shown that it lasts for about 8 to 10 weeks at the beginning of the cycle, and it doesn't really match very closely the end needs of the strawberry plant. So the cycling event in the organic fraction, microbial activity is a very dynamic situation, and on higher organic matter soils you can expect some additional nitrogen mineralization over the course of the season and nitrogen availability, but it's very difficult to control and to plan for. This was a study done with incubating different types of fertilizer sources, organic fertilizer sources, blood meal, feather meal, fish powder, in an incubation study done at UC Davis. And you can see here that even with these materials, much of those materials also were mineralized and had given up most of their nitrogen within 8 weeks. So in those situations where we have low soil organic matter, as in this case, this graph shows you the amount of mineralization that's likely to take place annually from different applications of or from mineralization of different amounts of soil organic matter. And even in those cases where we might have 3% organic matter, you still cannot expect very high mineralization taking place on an annual basis. It's certainly below 100 pounds of N per acre, but in those cases where we have 1 or 2% organic matter, we can't expect more than about 20 pounds of nitrogen coming available over the entire season just from the mineralization of organic matter. So it's clear from the plant end requirement that we need additional sources of nitrogen. It's not economical really to increase long-term organic matter in the soil. Most of our studies have shown this, so we really need this prior residue incorporation or rotation with a high N residue material or pre-plant compost application to even provide for initial nitrogen sources, but that is not sufficient to maintain the crop over the entire season. So here's overall our asynchrony problem, in that you saw that we're preparing these beds back in August and September, preparing beds, applying plastic and the drip tape and so forth. We've incorporated either compost or the prior residue from a broccoli crop or pre-plant green manure incorporation, but by the time, so then we get a big burst of nitrogen availability in the soil corresponding to this graph over the following 6 to 8 weeks, 10 weeks possibly in cooler climates, but plantings taking place in week 4 or 5, and then depending on the growing area, in some of our southern regions it's a little warmer, it starts a little bit earlier, and in southern northern regions it starts much slower, but clearly the soil is not able to provide nitrogen to the plant and adequate to the uptake requirements of the plant to meet the nitrogen needs of a growing strawberry crop. So we're clearly in need in-season fertigation. We need to be injecting nitrogen from organic fertilizer sources, so possibly beginning in about week 10 or 11, and earlier in the southern districts and later in the little more northern districts. And basically, especially in low organic matter soil situations, we'll probably need to be injecting on a weekly basis. So it's not really possible to, in our strawberry growing system, to use, where we have plastic beds and drip tape, to use any type of in-season band application like you might use on a vegetable crop or a shorter cycled crop. It's just not really impractical with our current production system as practiced in California. And so we really depend on fertigation from liquid organic fertilizer applications via drip tape. And this is the basis and is typically popular for among organic strawberries producers in California, but we have some lingering issues also with fertigation and the ability to control nitrogen fertilization of the plant via fertigation. We have a lot of anecdotal data that is, or experience that has accrued over the past several seasons, and growers observe that the plants are always smaller. Organic growers who grow both organic and conventional plants, the same variety, in some cases in neighboring fields, or certainly under similar management circumstances, organic growers often notice that plants are much smaller and yields are consistently lower relative to conventionally grown varieties, or a conventionally grown production system, not varieties. We're talking about the same variety in most circumstances. They've also noted rapid plugging of system filters, of drip system filters systems, and most irrigation engineers, I don't know an irrigation engineer that would ever recommend that you inject below the filter, but many growers out of frustration have begun injecting out of in some of organic fertilizer materials without a filter after the injection. We also have done multiple field studies in which we have injected varying rates of different fertilizers, in some cases doubling the rate in comparison replicated field trials, and not seen an effect on either on soil nitrogen or on yield from the varying field trials when we're doing different rates of injection. And then in addition to this, we have deterioration in what is referred to as distribution uniformity. Irrigation engineers here pretty routinely go into drip irrigation fields and measure distribution uniformity, which is the pressure and flow coming out of the tape at different parts of the field. And normally below 85% is considered unacceptable for managing a commercial production field, and it's not unusual for some of our fields to fall to 60% even after 4 to 8 weeks of injection. So you can see that, and then additionally, in some cases, we just don't see adequate tissue N even in those situations where we're fertigating organic strawberries. So we have some questions, and we've had questions over the efficiency of fertigation systems. That led me to set up a trial a couple of years ago. In the initial trial, we set up a long run of tape and replicated layout in the field where we could actually set up an experiment to inject different types of organic fertilizers and then sample the emitter, what the flow coming out of the emitter and the pressure in the lines at different times. And so we did weekly injections of different types of organic fertilizers, and then monitored nitrogen in the line and then at various points along the irrigation line and coming out of the emitter tape. So we were able to set up a system where we could collect flow coming out of multiple emitter tapes and into a bucket over an hour-long period, and begin then to compare different organic fertilizers and their efficiency, because we could then analyze that the material that actually came out of the emitter tape. And in that case where we were actually injecting above a filter, and that would be kind of the routine situation, we were able to maintain this system. So our incoming nitrogen, the nitrogen just coming out of the water supply was in the range of 0.6 pounds per acre, and then we injected starting right off either 2 pounds of N per acre per injection, or 4 pounds of N per acre, and then eventually getting to 8 pounds of N with weekly injections. So these were two types of typical liquid organic fertilizers, a fish-based material and a soy-based material, and this is what we typically saw coming out of those emitters. In other words, only 0.6 pounds of N per acre, well, initially even 0.2 to 0.4, basically 5 to 10% of the N being injected based on our injection rate was actually recovered coming out of the emitter with a 1 hour run time. So you can see that over the course of the season, this remained pretty consistent between these materials, and we're typically getting back a little more than 10%, in some cases 15, 20%, but very disappointing amounts of nitrogen. So a lot of nitrogen is being held behind the filter when we inject liquid organic fertilizers. And then we ran it again with injection below the filter, as many growers had turned to out of frustration. We saw a little bit more nitrogen coming out, and In other words, we would perhaps get 25 to 50% of the nitrogen that we injected, we'd get back coming out of the emitter when we didn't use a filter, but in week 17 the system was unusable. It slowly deteriorated, pressure deteriorated, and flow deteriorated in these lines, and by week 17 the system was unusable, and this was very similar to what we found with growers. Okay, I'm going to turn this over to Joji, and Joji will explain some of the work that he's been doing with field trials, and of course at the end we'll have time for questions with you. Thank you very much.
Thank you, Mark, and hello everybody. This is Joji Muramoto of UC Syracuse. I'm going to present the later half of this webinar. Okay, first I'm going to talk about field trials on pre-plant and in-season nitrogen applications. The goal was to examine the effects of types and rates of pre-plant and in-season nitrogen applications to fruit yield and nitrogen dynamics in organic strawberry production in the Northern District of California. We conducted randomized block split plot design on-farm trials with in-season nitrogen as a main plot and pre-plant nitrogen as a split plot in Watsonville, California for 4 seasons. Each treatment had 4 replicates. We monitored fruit yield, soil inorganic nitrogen in 0 to 1 foot depth, and plant biomass nitrogen. We used cultivar seascape for all 4 seasons. And this is the detailed experimental design for the first 2 seasons. These experiments were conducted at 2 different sites of the same small-scale diversified organic farm. For the first season, in-season nitrogen application rates were 50, 100, and 150 pounds of nitrogen per acre with liquid organic fertilizer. The fertilizer was applied via fertigation biweekly from March to October. Pre-plant nitrogen treatments were Sudan grass summer cover crop, Sudan grass plus feather meal 50 pounds of nitrogen per acre, and Sudan grass plus compost 5 tons per acre. And we chose these treatments by using the grower's standard practice as a middle point in season and pre-plant treatments. For the second season, we tried slightly higher in-season application rates with a range of 75 to 225 pounds of nitrogen per acre. And for pre-plant nitrogen treatment, we included non-Sudan grass only and compost 10 tons per acre only treatment to see adding more nitrogen as an in-season application without pre-plant fertilizer could work. So here's the yield, marketable yield of each season. Left is the first season, and the right is the second. The blue range indicates typical organic strawberry yield in the region. Overall, the second season had a greater yield compared to the first season, and the typical local organic yield. And there are some differences between treatments, but none of these were significant at 5% level in both seasons. Here's soil inorganic and dynamics during the crop seasons. Again, left is the first season, the right the second. As you see, there are some significant treatment effect. For the first season, pre-plant feather meal application increased soil nitrogen in December, January, and February. For the second season, compost application increased soil nitrogen in December and in-season application in April. But overall, the difference in patterns of 2 seasons are much more striking. In the first season, the high peak at November dropped rapidly by April, and another peak appeared in August. In contrast, the second season started low and maintained a moderate level throughout the crop season. Now, how about the plant nitrogen uptake, which is the sum of nitrogen in plant biomass and nitrogen in total harvested fruits? The data shows cumulative nitrogen uptake throughout the crop seasons. In the first season, we found significant treatment effect only in June and none in the second season. Overall, a similar pattern, and the second season had a slightly greater nitrogen uptake at the end of the season, but both were less than 100 pounds of nitrogen per acre. So, to evaluate synchrony of nitrogen demand and nitrogen supply that Mark was talking about, we put soil nitrogen, inorganic nitrogen data, and plant nitrogen uptake data together. Here's an example from the first season. There weren't much treatment effect both in soil nitrogen and plant nitrogen dynamics So this could represent the entire first season trial. We also added precipitation data too. As you see, it turns out that this shows a typical asynchrony of nitrogen supply and nitrogen demand. As Mark said, plant nitrogen uptake in early season was low, but large soil end peak existed in early season, which came from the mineralization of the Sudan grass biomass nitrogen. This nitrogen peak was lost almost entirely during rainy winter. To estimate the amount of nitrogen lost during the winter, we calculated nitrogen loss from the first 20 weeks from the planting date, from the change in the soil inorganic nitrogen, A here, and nitrogen uptake by plants. Then apparent nitrogen loss was simply calculated by A minus B. Note that the losses include any kinds of nitrogen losses such as leaching, denitrification, runoff, and immobilization. Also, being open field monitoring, this loss does not account for any nitrogen mineralization took place between sampling points. So this is a rough and minimum estimate of nitrogen losses. Anyway, the amount of apparent nitrogen loss turns out to be about 100 pounds of nitrogen per acre, which is more than total nitrogen uptake of the entire season in this case. I wanted to emphasize, though, that this is not a rare example of asynchrony in our region, unfortunately. As Mark showed a similar example from strawberry field where broccoli residue were incorporated, nitrogen-rich crop residue incorporation in fall is a widespread practice both in organic and conventional systems in our region. And nitrogen loss during winter is an issue to be addressed given the ground and surface water nitrate pollution concerns. So how about the second season? Here's an example from Sudan grass pre-plant plot. The good news is the second season had much more favorable pattern of nitrogen synchrony. Soil nitrogen started low and kept moderate level of soil nitrogen during the entire crop season. And it had very low apparent nitrogen loss during the winter, which is slightly negative in this case. So some of you may be wondering why so much difference in the soil nitrogen in early stage between two seasons when Sudan grass was incorporated in both years. Well, this is related to the difference in maturity of Sudan grass at incorporation. Basically, the Sudan grass in the first season was incorporated at a much younger stage than the second season. It had much higher nitrogen content and lower C/N ratio compared to the second season. With a high C/N ratio of 31, the second year Sudan grass did not release nitrogen as it did in the first season. Okay, we conducted 2 more seasons of on-farm trials. This time with a large-scale specialized strawberry grower. For both seasons, 0, 150, and 300 pounds of nitrogen per acre of in-season applications, and 5 tons per acre of compost plus 75 pounds of nitrogen per acre of blood meal, and compost plus 150 pounds per acre of nitrogen by blood meal were compared. Again, these treatments were selected based on the grower's standard practice. Here's a marketable fruit yield data. Third season on the left and the fourth season on the right. This time we found significant difference in both years, but in a completely different way, which makes our lives interesting, to say the least. In the third season, we found significant effect of in-season nitrogen application. The higher the in-season rate, the greater the yield throughout the yield, although the overall yield was relatively low. No significant effect of pre-plant nitrogen. In the fourth season, on the other hand, pre-plant nitrogen showed significant effect, but not in-season nitrogen. Overall yield was much higher than the third season. Further, in the fourth season, cull fruit rate, which is non-marketable fruit rate, showed in red lines actually increased as in-season nitrogen rate increased, which is not a good thing. So to understand this, we looked at the weather data in the winter of each year. Precipitation mean maximum air temperatures and minimum air temperatures are shown in the table, along with mean apparent nitrogen loss in each winter, November 1st to January 1st of the 4 seasons. As you can see, the amount of precipitation and air temperature varied among 4 winters. The first season had the wettest winter, and the second and fourth, the drier. Both the fourth season is the driest and the warmest, so this may explain a part of the significant effect of pre-plant fertilizer in the fourth season, because the warmer weather can stimulate early plant growth like it does in the southern region, and pre-plant fertilizer can be helpful in that case. So we conducted 4 seasons of trials, and here's what we found. Compost, we compared in season 1 and 2, no significant effect in yield and soil plant nitrogen dynamics in a single season. And the Sudan grass cover crop, low CN Sudan grass in the season 1 released nitrogen really quickly and caused large amount of nitrogen loss, as broccoli residues do. On the other hand, high CN Sudan grass crop residue didn't release nitrogen so quickly and basically behave like compost application in a short term. Blood meal tested in seasons 3rd and 4th, effective only in a dry, warmer winter year, as it works in the southern district, which may be much more common in the northern region too, due to the warming, global warming. In-season nitrogen fertilizer application, it's kind of striking that we didn't find any significant response in 3 out of 4 seasons. This experiment was conducted before Mark did his fertigation efficiency study, so we didn't check the distribution uniformity material. We checked the nitrogen content of material, but not the distribution uniformity. So that could be partially due to low distribution efficiency. But the highest rate, 300 pounds of nitrogen per acre, increased marketable yield in 1 season when overall yield is low, but increased cover rate in another season when high overall yield was high. So it's not consistent, unfortunately. Okay, how can we limit the nitrogen loss during the winter? To answer this question, we conducted regression analysis of 6 field trials with 53 treatment combinations and found that nitrogen loss is strongly dependent upon 3 things: amount of residual soil nitrate from previous crops, amount of nitrogen added in crop residue immediately before strawberries, and the amount of pre-plant organic fertilizers added, such as pelleted organic fertilizer or blood meal. And here the rule of thumb. To keep nitrogen losses below 50 pounds of nitrogen per acre, don't add any pre-plant organic fertilizer if residual nitrogen is above about 25 milligrams per kilogram in 0 to 1 foot soil depth, or broccoli residue were incorporated before planting strawberries. To summarize today's webinar on nitrogen management in organic strawberries, first we discussed nitrogen demand by strawberries. It varies depending on the region and fruit yield. In the southern warmer region, nitrogen uptake increases faster than northern colder region. So pre-plant nitrogen can be more effective in the south than the north, and it can increase fruit yield in dry, warm winters in the north. And total nitrogen by uptake by strawberry can vary from 90 to almost double, 180 pounds per acre, depending on the yield. And mineralized nitrogen from a crop residue, organic fertilizer, and soil organic matter does not match the long and steady nitrogen needs of strawberries, so in-season nitrogen application is necessary. Also, mineralized nitrogen from crop residue and residual soil nitrate are the major sources of excess nitrogen in fall and vulnerable to loss during rainy winter season in the north. And a guideline to limit nitrogen loss was provided. Fertigation of liquid organic fertilizer, a common practice as the in-season nitrogen application, but has efficiency issues to be addressed. Low yield of organic strawberries may partially be due to the low N sufficiency during the harvest season. might be a possibility. So future studies, improving fertigation efficiency in organic strawberries. Mark is going to examine effect of filter mesh size, high pressure agitation in a mixing chamber prior to injection on organic wetting agent and dispersant. Also, how to reduce the nitrogen loss during rainy season. We are trying to develop N-loss estimation tool based on regression analysis. And we are also interested in trying high CN organic amendments to immobilize residual soil in organic nitrogen. And we need to know more, we need more understanding about the interaction between plant health and nitrogen demand. Low yield of organic strawberries due to pathogen infection, nitrogen deficiency, or both. And recently we've been working on the method called anaerobic soil disinfestation. Some of you may have heard and doing it, but can control some plant pathogens. And in that situation, what's the nitrogen dynamics? We need to study that too. Mark and I co-authored a chapter of Organic Strawberry Production Manual, which covers the basics of today's webinar presentation. So that might be a good reference. And it's some examples of the nitrogen fertility schemes in there too. Also, Netafim irrigation company has some information about how to manage irrigation system when organic nutrients are used. That's kind of interesting reference too. We would like to acknowledge funding from USDA, ORA funding, and collaborative growers, Manzanita Farms, High Ground Organics, Ryder affiliated companies, Briscoe's, Cypress Consulting, and funding from San Luis Obispo and Santa Barbara counties, and help from staff, students, and volunteers of the Shannon Lab and Greenspan, UCSC. Time for discussion, but you can reach us by email, by these emails, if you have any questions. Thank you very much.
Thank you. We're about to begin our question and answer sessions. So let's move on to the questions. I know we've been getting quite a few coming in already. A couple of general questions about organic strawberry production in California first. Do you happen to know the size of organic strawberry growers on average in California?
I know growers who have, it's unusual I have not seen many farms over 100 acres, and I would bet that it would be unusual to see them over about 25 or 50 acres. So I'm guessing that it's probably an average maybe in the 20 to 25 acre maybe.
Okay, thanks. And in terms of the bed preparation process, does that happen year after year, or do they have perennial plants producing, or how often is that whole process repeated?
Well, one thing I explained was that the traditional system was based on annual planting. In other words, you would tear the field up every August and September and replant annual plants out of northern nurseries or coolers. That has, because of the marketing interest in marketing and the development of more competitive day-neutral varieties that aren't dependent upon day length for their flowering cycle, that has now extended. So there's a wider range of planting times. Now planting proceeds, and there are what are referred to as summer plantings that take place in the spring for late summer harvest and in an annual system. And then there are some of the fields that were harvested, for example, with the graph that I showed you there, might be cut back. The plants cut all the way down to the surface of the bed in August, and then those plants come back, and because they're day neutral, they'll start flowering and fruiting again in early October and fruit through the winter. Even more so, I would think, in more central and southern regions, because our rainfall is also lower, in addition to the temperature being a little warmer than the more northern districts.
Okay, we have a couple of people that asked about what happens to that nitrogen that gets held up in the irrigation, pre and post filter.
Well, we don't know exactly, but the fact is drip system and microirrigation filter systems are designed to remove particles from water. So organic fertilizers typically are very finely ground suspensions of organic material. And so when you analyze a fertilizer, you're analyzing the total nitrogen, phosphorus, and potassium, and so forth. And that is a suspension. There is a component in each one of those that is actually a soluble nitrogen form, but that's relatively small compared to the amount that is in very fine, and it's finely ground, and in many cases the manufacturer grinds it initially and screens it to pass a very fine mesh, but then it becomes, well, it's almost a living solution in the sense that algae and bacteria and fungi continue to work on that material and will actually then transform it once it's wetted again. So that that's why it's a little hard to predict the material that you're actually injecting through the line. But if you're using a filter, it stays behind the filter, and if you're using an emitter, it stays behind the emitter. Conceivably, some additional transformation can take place within the filter and within the line. The bacteria will continue to mineralize and break down those fine organic matter particles, but you just don't have any control whatsoever in the rate and timing and the flow of that nutrient pool.
Okay, let's see. What was the level of nitrogen in the compost that was used in the 5-ton and the 10-ton per acre treatments?
That was a question to me, I think, and it was about 1%. It was a dairy manure-based compost.
Okay. You mentioned that you're looking for the causes of the reasons for why there are smaller plants in organic systems. And one person asked whether the lack of fumigation would be one of the reasons for smaller plants. Do you think?
Yeah, that's part of it. And I'm trying to figure out what part is actually, how much is the part due to the soil-borne disease, and what part is nitrogen deficient or nutrient deficient. And I think I did a lot of tissue tests for organic strawberries too, and in many cases nitrogen is actually sufficient. So which tells that more to do with diseases, not by the nutrients, but we still don't know what exactly the case.
Okay. Are organic growers in California using mustard meals pre-plant?
Some are. Some growers use it. But we did some experiment and with different rate, 1 tons to up to 2.5 tons, the maximum, or actually 3 tons. But yeah, results are so far mixed. And also mustard seed meal shape or form of mustard seed meal seems to be important, to be very important in terms of effectiveness. Mustard seed meal not just supply nitrogen but also suppress soil-borne disease in some cases. But if it's pelleted, active ingredient release seems to be much lower than powdered or powdered.
Okay, we have a couple questions about cover crops. Were any other cover crops tested other than Sudan grass?
We have not. Sudan grass is the most popular summer cover crop for strawberries, but even that particular grower who collaborated with the experiment, he decided this day he's not doing the Sudan grass cover crop because of the lot of the organic matter that actually hinders nice bed shaping. So he just switched to compost.
Okay, and another question about Sudan grass. Did the Sudan grass for the second season trial perform better since it's harvested when it's dry and thus it's tougher to decompose?
Yeah, the thing is the Sudan grass was much mature. It's almost flowered before flowering, and then was much more carbon in it. So it didn't release nitrogen. And in fact, I think it's immobilized some of the residual nitrogen, and then eventually released nitrogen in the later season. So it turns out worked well. But we didn't find any difference between with and without Sudan grass. So it's kind of hard to see the effect in a single season.
Okay. When you did this study, did you relate it to an economic analysis as well?
Yes, we did. Actually, that's something we have to do more formally, but yeah, that's in progress. And yeah, in the near future, we plan to publish those data too.
Okay. Let's see. This person is from Minnesota. So, what effect would frozen soil have on the release of nitrogen?
That's an interesting question. We never had frozen soil here, so I have no
Generally, the mineralization rate falls pretty dramatically below 50 degrees Fahrenheit. So a lot of times it's essentially stopped. I mean, you usually calculate almost no mineralization between. It's probably continuum as you go down to freezing. But when we start getting soil temperature below 50 degrees, then mineralization slows. And, you know, in the Midwest and in more northern climates, really soil's more likely to stay in ammonium forms and organic forms over the winter months, and the mineralization to nitrate doesn't occur until spring temperatures start warming up.
Okay. If an organic mulch were used rather than plastic, would side dressing of compost or inorganic material be possible?
Possibly. I mean, you'd have to pull the mulch back probably, and then because you can ban, I mean, types of materials can be band applied in traditional vegetable crops, and we pretty much routinely do that in organic production of other crops in California. And it's but the advantages of having plastic mulch related to fruit quality and uniformity and plant growth, I think it would really mean a total transformation in the production system. If we start really verifying that only 1/10 of the applied fertigated nitrogen is getting to the plant, you might see more interest. I mean, now the industry is looking at all kinds of additional possibilities, growing on artificial substrate and growing in other types of combinations of substrate and artificial growing environments and so forth. So we may see that happening anyway, but for now, the bulk of the organic strawberry production acreage and volume is based on our traditional strawberry growing system.
Okay, there are a couple questions coming about specifics of irrigation systems. Some growers use low-pressure sprinkler heads called Sunninger wobblers. Can fertigation be injected in those? Anyone?
I don't have data with those. If an irrigation engineer is not going to recommend that you inject without a filter, in other words, that you would inject below a filter, so you still have to get it by the filter. But I don't have any experience with low-pressure sprinklers.
Okay, one more question about that. Let's see, could you mention some specifics about the findings in the irrigation efficiency study? Disc filters versus screen filters. On our farm, we fertigate below the filter and definitely have some clogging problems. Do you have any specific advice about mitigating clogging and increasing the efficiency? So I can take that one at a time if you like, but.
Well, I just can't, I mean, we have growers now who are putting double drip tape in their bed, and they change the tape over mid-season. And that doesn't solve the problem because you still aren't, I mean, you might keep the flow going to the plants, but you have to realize that it's not just the tape that's getting plugged and the filter that's getting plugged. The water isn't getting to the plant either, so you aren't getting nitrogen and or water to the plant consistently, and you know, as far as the distribution uniformity that I described for you. So I don't see a way that we have to come up with materials that are going to be more soluble, I think. I think we're going to have to come up with organic fertilizer sources that are more soluble, that aren't essentially suspensions of fine materials.
Okay. Did you find that specific liquid fertilizers clog less than others? We use AgroThrive liquid fertilizer on their farm.
We really haven't had, we've only done these 2 trials, and we're just now beginning to get some of the first quantifiable data back. There may well be materials out there. Of course, if they have a higher percentage of soluble nitrogen, I would still expect the soluble nitrogen to get through, to get by the filter. But I haven't gone through by any means and compared organic fertilizers, and I don't have any idea. I suspect that this is fairly widespread, but I really can't prove that. I don't know that.
Okay. Your studies reference nitrogen losses only from 0 to 1 foot depth. What depth is the nitrogen loss to? So if you would follow strawberry production with a deeper rooted crop, would you be able to recover that lost nitrogen?
That's possible, especially, you know, if you grow winter cover crop. Depends on the timing of the cover crop growth, but some studies suggested that grass cover crop can recover the nitrogen in a deeper layer. But the strawberries have very shallow roots, and especially in the early season. So that's why we focus the top 30 centimeter, or 1 foot.
Okay, here's a question about whether or not you know whether foliar application of compost or agricultural teas is currently used by any strawberry growers.
I think some growers use it, but yeah.
Okay.
I know some use it.
I don't know of growers that use it. Foliar fertilizers need to get, you know, traditional foliar fertilizers. I think for organic certification, you have to demonstrate a deficiency to get approval by the certifier. But in compost teas, I think some of the issue has to do mostly with the uniformity of the material that you're producing and reliability. But I personally do not have experience with the compost teas.
Okay. Do you have any data on underground irrigation with no filtering system?
Is that referring to underground drip tape or subbing up with underground water, high water table?
Okay, subbing up.
I don't have that experience.
No.
Okay. Let's see. Do you have any experience with hydroponic organic strawberries and fertilization?
Nope.
Okay.
You still need, I mean, hydroponic even more so. You depend on the material. Well, I mean, you could conceivably bathe the roots in an organic solution that didn't go by a filter, I guess. In that particular case, you perhaps would be using a larger pipe or chamber or something like that, whatever hydroponic system. But if you were putting it through tape, you still have this problem. But I don't have that experience. No, I'm sorry.
Okay. Let's see. Early in the presentation, the comment was made that changing soil organic matter levels was not cost effective. Is that due to land costs in California or the physical inability to change organic matter in annual systems or something else?
Well, yeah, I think the issue would be you'd have to apply enough of a organic material. We just did a little study with biochar because biochar is, in some circumstances, depending on the source material, can be a long-term organic matter source. it did not affect our long-term organic matter in soil. So if you did repeated compost application, you're still getting that mineralization and turnover of nitrogen, and eventually the organic material gets spent because there just are not, we don't have that type. You would need to come up with a system whereby the land possibly was being utilized as a dump site for wood waste or something like that, where you're actually getting a buildup of more lignaceous and resistant organic materials that would break down much more slowly. But with current cropping systems and cropping practices, you would have, in one sense, the person's right when they mention the high cost of land. The grower just couldn't afford to take the land out of production long enough period of time. And then, of course, if you're putting a huge amount of even compost on at one time, then you get into the problems that Joji described with even if it's 1%, you start putting on 50 tons or something like that, you're going to get a leaching problem with nitrogen and phosphorus for that matter.
Okay, here's someone who says he's thinking of trying urea in his small experimental plot. That should have less problem with deposit in the system. Want to comment on that?
Urea, well, it's not allowed in the organic system, I don't think. So it's in conventional.
No, it's not.
Yeah, it's just fine, but not in the organic system.
Okay. Let's see. In Wisconsin, the first year plants are established, and in the second year we harvest the first crop. Would there be any benefit of incorporating pre-planting nitrogen? Would a high CN ratio plant material release nitrogen in the second year?
Yeah. Well, the cropping system is totally different, and I have no experiences with so-called matted row system in those regions. So, yeah, I can't comment on that. Sorry.
Okay. Let's see, a couple more questions here. Could nitrogen be applied at the wrong time, encouraging vegetative growth rather than fruit growth?
That's a typical symptom of over-application of nitrogen. But the strawberry is very complex crop. If you have too much chill hours, same thing could happen. You have more plant vigor but less fruit. So it's a little bit complex. But definitely if you apply too much nitrogen, especially in the early stage, that tends to produce more vegetative than fruit.
Okay. Can bios...
Oh, sorry. Because we're basically trying to build a plant structure initially that then you hang and larger, more branches, and the larger the branches you get at the beginning allow you to have a bigger structure on which to set berries. But then growers here tend to cut back a little bit during in-season maintenance applications, a little bit on nitrogen and emphasize more potassium, but you still do need the larger plant on which to hang the fruit yield.
Okay. Can biostimulants release nitrogen from high organic matter soils later in the growing season?
Biostimulant? I'm not familiar
sure
with
what
that.
That is. If you want to clarify, we'll just give them a couple of seconds. If you could clarify what you mean. Okay, and while that's happening, would the same leaching happen in areas that are growing blueberries or raspberries?
It depends on the weather pattern and the amount of nitrogen that are coming in. If it's a similar situation, same kind of nitrogen loss could happen.
Okay, well, that's pretty much it for the questions, unless we get a clarification on the biostimulants. So we'll have a couple seconds for that. But in the meantime, I just want to thank everyone for all your questions and encourage you to check out our many other upcoming and archived webinars, including one that Joji was involved with on anaerobic soil disinfestation from a couple of years ago at the link on your screen. So yes, here we go on the biostimulants, last bit here. They are biological products that are being sold on the market to stimulate microbial activity. So do you have any experience with those?
No, we haven't tried that kind of thing yet.
Okay. All right, well, thanks everyone for coming, and we look forward to future webinars to hear more about the new trials that are coming up.